Take a slow breath in, and as you breathe out, imagine the soft sound of wind moving across a wide, frozen landscape. Tonight, we begin a calm journey into one of the quietest forces shaping our planet: glaciers. Glaciers are often imagined as distant and silent, tucked away in remote mountains or at the edges of the world. Yet, they are powerful storytellers of Earth's history, holding memories of ancient climates, shaping valleys, feeding rivers, and influencing global systems that affect travel, tourism, ecosystems, and even modern economies. In this gentle exploration, we will move slowly through soothing glacier facts, letting each idea settle comfortably in your mind. If you're listening at night, allow your eyes to rest. If you're listening during the day, let this be a moment of calm curiosity. And if you find these stories of ice relaxing and enjoyable, you're always welcome to like the video, subscribe for more peaceful learning, and leave a comment sharing your country, your city, and the time you're listening from. Many people enjoy knowing they are part of a quiet, global audience, drifting together across time zones. Now, let us begin. A glacier is not simply frozen water. It is a living river of ice, slowly flowing under its own immense weight. For ice to become a glacier, snow must accumulate year after year, compressing layer upon layer until air is squeezed out and dense ice forms. This process can take decades or even centuries, which means every glacier is a long-term archive of Earth's climate history. Some of the oldest glacier ice on Earth is found in Antarctica, where ice cores have revealed atmospheric conditions stretching back more than 800,000 years. Tiny air bubbles trapped within that ice preserve samples of ancient atmospheres, offering scientists insights into past temperatures, carbon dioxide levels, and natural climate cycles. This quiet, frozen record has become essential to modern education, environmental science, and global climate research. Glaciers cover about 10% of Earth's land surface today. They are found on every continent except Australia, appearing in high mountain ranges such as the Himalayas, Andes, Alps, and Rockies, as well as in vast polar regions like Greenland and Antarctica. These frozen landscapes often become destinations for adventure, travel, and luxury ecotourism, drawing visitors who wish to experience pristine nature shaped by ice over thousands of years. One calming fact to remember is how slowly glaciers move. Despite their enormous size, most glaciers flow only a few centimeters to a few meters per day. This slow movement is almost imperceptible to the human eye, yet over long periods, it transforms entire regions. Valleys become wider and deeper, mountainsides are smoothed, and rocky debris is carried great distances. Many of the world's most scenic landscapes, including fjords and U-shaped valleys, owe their beauty to glaciers. Glaciers also play a critical role in fresh water supply. In many regions, especially in Asia and South America, meltwater from mountain glaciers feeds major rivers that support agriculture, cities, and economic development. The Indus, Ganges, Yangtze, and Mekong rivers all depend, in part, on seasonal glacier melt. This connection between frozen peaks and daily human life reminds us how deeply interconnected Earth's systems truly are. There are different types of glaciers, each with its own gentle story. Valley glaciers flow down mountain slopes, following paths carved by gravity. Ice caps spread outward in all directions, covering entire landscapes beneath them. Ice sheets, the largest of all, blanket continents with ice thousands of meters thick. Antarctica's ice sheet alone contains enough frozen water to raise global sea levels by many meters if it were to melt completely. A thought best held calmly and without urgency in this quiet exploration. The surface of a glacier is rarely smooth. Crevasses form as ice stretches and cracks, creating deep blue fissures that reveal the glacier's inner layers. That blue color is not reflected sky, but compressed ice, absorbing red wavelengths of light and scattering blue ones. It is one of nature's most soothing and beautiful optical effects, often photographed by travelers and featured in documentaries about Earth's natural wonders. Glaciers are also surprisingly noisy, though their sounds are subtle. As ice shifts and melts, it can produce gentle pops, cracks, and distant rumbles. In polar regions, when large chunks of ice break away into the sea, the event is called calving. The resulting icebergs drift silently across cold waters, becoming part of the global ocean system. Some icebergs travel thousands of kilometers before melting completely, slowly releasing fresh water into the ocean. Long before modern science, glaciers shaped human history. During the last ice age, massive ice sheets covered much of North America and Europe, forcing early human populations to adapt, migrate, and innovate. As the ice retreated, fertile lands were revealed. Rivers formed new courses, and ecosystems flourished. Many of today's major cities, transportation routes, and economic centers exist where glaciers once flowed. In art and culture, glaciers have often symbolized patience, endurance, and quiet strength. Writers, painters, and explorers have long been drawn to icy landscapes for their sense of stillness and scale. Even today, glaciers inspire calm reflection, reminding us that not all change is fast, loud, or dramatic. Some of the most powerful forces on Earth move slowly and silently. As we continue through this series, we will explore how glaciers form, how they move, how they shape landscapes, and how they connect to oceans, weather patterns, and life itself. Each fact will be presented gently, like footsteps across fresh snow, leaving only a soft trace behind. For now, allow the image of a glacier to settle in your mind. A vast river of ice, glowing softly under a pale sky, moving steadily, patiently, shaping the world without hurry. As we continue drifting gently forward, imagine light snow falling in a quiet mountain valley. Each snowflake lands softly, barely noticed. Alone, it seems insignificant. But together, over time, these tiny crystals begin one of the most remarkable processes in Earth science, the birth of a glacier. Glaciers begin their lives not as ice, but as snowfall that refuses to disappear. In regions where winters are long and summers are cool, more snow falls each year than melts away. Layer by layer, season after season, the snow accumulates. The weight of new snowfall presses down on older layers beneath, slowly compressing them. Air pockets shrink, snowflakes lose their delicate shapes. What remains is dense, granular snow called firn, a quiet halfway stage between snow and ice. This transformation from snow to glacier ice can take anywhere from several decades to a few hundred years. It is an unhurried process, perfectly suited to patience. Over time, firm becomes so compressed that the air bubbles inside are sealed off, creating solid ice. Those trapped bubbles become time capsules, preserving tiny samples of Earth's ancient atmosphere. This is why glaciers are invaluable to education and science, offering insights no written record could ever provide. Once enough ice accumulates, gravity takes over. The glacier begins to move. This movement is what separates a glacier from a simple snowfield. Even though the motion is incredibly slow, the ice flows like a thick, frozen river. Some glaciers slide over the ground beneath them, lubricated by meltwater. Others deform internally, with ice crystals slowly shifting past one another under immense pressure. This slow movement gives glaciers their unique power. As they flow, they pick up rocks, soil, and debris from the landscape. These materials become embedded in the ice, turning the glacier into a massive, natural conveyor belt. Over time, glaciers carve valleys, sharpen mountain peaks, and sculpt entire regions. Many of the world's most famous natural wonders owe their shapes to this quiet process. The formation zones of glaciers are called accumulation zones. These are areas, usually at higher elevations or latitudes, where snowfall consistently exceeds melting. Below this lies the ablation zone, where ice is lost through melting, evaporation, or calving. The balance between these two zones determines whether a glacier grows, shrinks, or remains stable. This balance is carefully studied by scientists monitoring long-term environmental trends. In mountain regions like the Alps, Andes, and Himalayas, glaciers often form in shaded, cirque bowl-shaped depressions carved into mountainsides. These natural basins collect snow efficiently, protecting it from sunlight and wind. Over time, the glacier grows outward, flowing down valleys and shaping the terrain below. These landscapes later become popular destinations for hiking, skiing, and ecotourism, blending natural beauty with sustainable travel experiences. Polar glaciers follow a slightly different path. Snow. Antarctica. Snow accumulates over vast flat areas, forming ice caps and ice sheets rather than valley glaciers. Antarctica's ice sheet is the largest single mass of ice on Earth, covering an area larger than the United States and Mexico combined. In places, it is more than 4 kilometers thick, pressing down on the continent beneath it. One calming detail is that glacier ice behaves differently depending on temperature. Warmer ice, closer to melting point, flows more easily than colder ice. This means some glaciers move faster than others, even if they appear similar on the surface. Yet even the fastest glaciers move slowly by human standards, often advancing only a few meters per day. The color of glacier ice tells part of its story. Fresh snow appears white because it reflects light in all directions. As snow compresses into ice, air bubbles decrease, allowing light to pass through more deeply. Red wavelengths are absorbed, leaving behind that deep, tranquil blue, often associated with glaciers. It is a color that feels cool, even to the imagination. Glacier formation is also deeply connected to global weather patterns. Regions influenced by steady moisture such as coastal mountains, where ocean air rises and cools, are more likely to host glaciers. This is why places like Alaska, Norway, and New Zealand support glaciers despite relatively moderate latitudes. The oceans, atmosphere, and ice work together in quiet coordination. For much of human history, glaciers were seen as mysterious and even threatening. Early communities feared advancing ice, which could overrun farmland and settlements during colder periods. Today, glaciers are studied with calm precision, using satellites, drones, and ground measurements. They have become indicators of long-term environmental change, valuable not for alarm, but for understanding Earth's natural rhythms. As you rest with these thoughts, imagine standing near the birthplace of a glacier. Snow falls gently. The air is still. Yet, beneath the surface, time is at work. A river of frozen history begins its slow journey downhill. As we continue gently onward, imagine standing beside a glacier at dawn. The air is still. The ice appears completely motionless. Yet beneath this calm surface, something extraordinary is happening. Glaciers move. Not suddenly, not dramatically, but with a patience that mirrors geological time itself. A glacier flows because of gravity and pressure. As ice builds up and thickens, its own immense weight causes it to slowly deform. Unlike brittle ice in a freezer, glacier ice behaves more like a very slow, viscous fluid. Individual ice crystals slide past one another, adjusting their shapes under pressure. This process is known as internal deformation, and it allows glaciers to move even when frozen solid to the ground beneath them. In many regions, glaciers also move by basal sliding. At the base of the glacier, pressure and friction generate a small amount of meltwater, even in sub-zero conditions. This thin layer of water acts as a lubricant, allowing the ice to glide slowly over rock and sediment. The warmer the glacier and the more meltwater present, the faster this sliding can occur. Still, fast, in glacier terms, usually means a few centimeters or meters per day. Some glaciers move so slowly that their motion can only be detected by long-term measurements. Others, known as surge glaciers, experience brief periods of faster flow, sometimes advancing several meters per day before settling back into dormancy. These surges are still being studied, offering fascinating insights into the interaction between ice, water, and underlying geology. As glaciers move, they shape the land with quiet determination. Rocks frozen into the base of the ice scrape against bedrock, polishing it smooth and carving long grooves called striations. Over thousands of years, this abrasion transforms sharp valleys into wide, U-shaped corridors. Many famous mountain valleys, from Yosemite to the European Alps, were carved by glaciers long before humans arrived to admire them. Glaciers also pluck rocks from the landscape. As meltwater seeps into cracks in bedrock and refreezes, it expands, loosening fragments. When the glacier continues its slow advance, it lifts these rocks and carries them away. This process creates jagged peaks and steep valley walls, contributing to the dramatic scenery that now supports tourism, photography, and outdoor recreation across the world. At the glacier's edge, ice is constantly being lost through melting and calving. Calving occurs when large blocks of ice break off, often into lakes or oceans. This process can be surprisingly gentle, with soft echoes as ice separates and drifts away. In polar regions, calving glaciers feed icebergs into the sea, beginning long journeys shaped by ocean currents and winds. Moraines are another signature of glacier movement. These are ridges of rock and debris deposited where glaciers slow down or retreat. Terminal moraines mark the furthest advance of a glacier, while lateral moraines line the sides of valleys. Today, these features help scientists reconstruct past climates and help travelers understand the history written into the landscape. One soothing thought is that glaciers respond slowly to change. Glaciers take decades or centuries to react to differences in temperature and snowfall. This makes them valuable long-term indicators in earth science and climate education. Their movement is not chaotic. It is steady, measured, and deeply connected to natural cycles. Glaciers also play a role in water systems. As they move and melt, they feed rivers that support ecosystems, agriculture, and human settlements. In many regions, glacier-fed rivers provide reliable water during dry seasons, acting as natural reservoirs. This connection between frozen landscapes and daily life is one of the most elegant examples of Earth's interconnected systems. Despite their size, glaciers are sensitive. A small change in average temperature can shift the balance between accumulation and melting. When melting exceeds snowfall over long periods, glaciers thin and retreat. When snowfall dominates, they grow and advance. This balance has shifted many times throughout Earth's history, shaping continents again and again. As you rest with this knowledge, imagine a glacier moving beneath the stars, silent, patient, unstoppable in its own time. Every centimeter of motion tells a story of pressure, gravity, and persistence. Nothing is rushed. As we continue drifting calmly forward, imagine a world shaped slowly, patiently, and almost invisibly by moving ice. Long before cities, roads, and borders, glaciers acted as quiet sculptors, carving some of the most breathtaking landscapes on Earth. What we admire today as natural beauty is often the result of ice working steadily over thousands of years. One of the most recognizable glacier-carved features is the U-shaped valley. Unlike rivers, which cut narrow V-shaped valleys, glaciers move as wide, heavy masses. As they flow downhill, they grind against valley floors and walls, widening and deepening the terrain. When the ice eventually melts away, it leaves behind broad, flat-bottomed valleys with steep sides. These valleys now host meadows, rivers, towns, and travel routes, blending natural history with modern life. High above these valleys, glaciers also sharpen mountain peaks. When several glaciers erode a mountain from different sides, they create pointed summits known as horns. The Matterhorn in the Alps is one of the most famous examples, rising dramatically against the sky. These sharp peaks are the result of ice removing rock layer, leaving behind striking silhouettes that draw climbers and photographers from around the world. Another beautiful formation is the cirque, a bowl-shaped hollow carved into mountainsides. Cirques form where glaciers begin, slowly rotating and deepening their beds. After glaciers retreat, cirques often fill with clear, alpine lakes called tarns. These quiet bodies of water reflect the sky and surrounding peaks, offering peaceful scenes that feel timeless and untouched. Perhaps the most majestic glacier-carved landscapes are fjords. Found in places like Norway, New Zealand, and parts of Canada, fjords are long, narrow inlets with steep cliffs rising straight from the sea. They were once glacial valleys that extended below sea level. When the ice melted and sea levels rose, ocean water filled these valleys, creating deep CLM waterways, now famous for tourism, luxury cruises, and nature-based travel. Glaciers also leave behind hanging valleys. These occur when smaller tributary glaciers join a larger main glacier. Because the main glacier erodes deeper, the smaller valley is left suspended above it after the ice disappears. Today, hanging valleys often feature waterfalls cascading gracefully into larger valleys below, adding motion and sound to otherwise still landscapes. As glaciers retreat, they deposit sediment in distinctive ways. Outwash plains form where meltwater spreads fine sand and gravel beyond the glacier's edge. These flat areas often become fertile ground for vegetation and agriculture. In some regions, they later support towns and infrastructure, quietly linking ancient ice movement to modern economies. Erratic boulders are another reminder of glacier travel. These large rocks are carried far from their original locations and deposited when the ice melts. Often, their composition differs from the surrounding bedrock, making them stand out as solitary monuments. For centuries, people wondered how such massive stones arrived in unlikely places. Long before glacial science offered an explanation, drumlins, shaped like smooth, elongated hills, form beneath moving glaciers. They align in the direction of ice flow, creating landscapes that appear gently combed by nature. From the air, drumlin fields resemble soft waves frozen in place, adding to the quiet poetry of glacial terrain. Glacial lakes also emerge as ice retreats. Some form behind natural dams of rock and sediment left by glaciers, while others occupy depressions carved into bedrock. These lakes are often cold, clear, and deep, reflecting surrounding mountains and forests. They support freshwater ecosystems and provide scenic destinations for travelers seeking calm and reflection. The influence of glaciers reaches coastlines as well. In polar and subpolar regions, glaciers extending into the sea calve icebergs that drift silently through cold waters. These floating fragments of ancient ice carry minerals and nutrients that support marine life, linking frozen landscapes to ocean ecosystems in subtle but powerful ways. Every glacier-carved landscape tells a story of time and patience. Nothing about these forms is rushed. They are shaped slowly through countless freeze-thaw cycles and steady pressure. This makes them feel grounded, enduring, and reassuring in a fast-moving world. As you relax with these images, picture a valley slowly emerging as ice retreats, revealing smooth stone, fertile soil, and clear water. The glacier moves on, leaving beauty behind. Its work is done, but its influence remains. As we move gently forward, imagine ice not just as frozen water, but as memory. Glaciers are among the most reliable record keepers on Earth. Layer by layer, year by year, they quietly preserve stories of ancient climates, distant eruptions, and long-forgotten atmospheres. In their depths, time itself seems to slow. Each year, snowfall adds a new layer to a glacier. In colder seasons, snow tends to be lighter and finer. In warmer seasons, it is often denser, sometimes mixed with dust or pollen carried by winds. Over centuries, these seasonal layers become compressed into ice, forming visible bands, much like the rings of a tree. By studying these layers, scientists can reconstruct detailed timelines stretching back hundreds of thousands of years. One of the most remarkable features of glacier ice is the air trapped within it. As snow compresses into ice, tiny bubbles of air are sealed inside. These bubbles contain samples of the atmosphere from the time they formed. By analyzing them, researchers can measure past concentrations of gases such as carbon dioxide and methane, offering insight into how Earth's climate has changed naturally over time. Ice cores, long cylinders drilled from glaciers and ice sheets, are central to this work. Some ice cores, extracted from Antarctica, extend back more than 800,000 years. They reveal patterns of ice ages and warmer periods, showing how temperature, atmospheric composition, and sea levels have risen and fallen in gentle cycles across deep history. Volcanic eruptions also leave their signatures in glacier ice. Ash and sulfur particles settle onto snow after eruptions, becoming trapped in ice layers. These markers allow scientists to date eruptions precisely and study their global impacts. In this way, glaciers quietly record not only climate, but major geological events that shaped ecosystems and civilizations. Glaciers even preserve traces of ancient life. Pollen grains trapped in ice tell stories of vegetation that once thrived nearby. In some cases, microbes have been discovered frozen for tens of thousands of years, offering glimpses into life forms adapted to extreme cold. These findings contribute to education and research, expanding our understanding of biology and resilience. The clarity of glacial records comes from their isolation. High altitude and polar glaciers are far removed from human activity, allowing them to capture global signals rather than local noise. This makes them especially valuable for understanding long-term natural patterns rather than short-term fluctuations. As technology advances, scientists use lasers, chemical analysis, and isotopic measurements to read ice with extraordinary precision. Ratios of oxygen isotopes, for example, reveal past temperatures with surprising accuracy. Each frozen layer becomes a chapter in Earth's autobiography, written slowly but faithfully. Glaciers also help scientists understand how Earth's systems are connected. Changes recorded in ice often align with shifts in ocean circulation, vegetation, and even human migration patterns. This interconnected view supports a holistic approach to environmental education and long-term planning. Beyond science, there is something deeply calming about the idea of ice holding memory. In a fast-paced world, glaciers remind us that time can be gentle, that change can be gradual, and that the planet has endured far longer than any single generation. Many ice cores are now stored in secure archives, protected for future research. These frozen libraries ensure that even as glaciers change, their records will remain available for generations of scientists and students. This preservation effort reflects a shared global commitment to knowledge and understanding. As you rest with these thoughts, imagine a single snowflake falling thousands of years ago, now locked deep within a glacier. It carries with it a whisper of ancient winds and distant skies. Quietly, patiently, it waits to be read. As we continue calmly onward, imagine a clear mountain morning. Far above, a glacier rests in silence, yet far below, rivers flow steadily through valleys and plains. These two scenes are connected. Glaciers are not only sculptors of land and keepers of time. They are also some of Earth's most reliable natural reservoirs of fresh water. Nearly 70% of the world's fresh water is stored in glaciers and ice sheets. This makes them one of the most important components of the global water system. Although they may seem distant and remote, glaciers quietly support ecosystems, agriculture, cities, and economies across the planet. In many mountainous regions, glaciers act like slow-release water towers. During colder months, snowfall is stored as ice. When warmer seasons arrive, gradual melting releases water into rivers and streams. This steady flow helps maintain water levels during dry periods, supporting crops, wildlife, and human communities. In this way, glaciers balance extremes, smoothing out seasonal changes with remarkable consistency. Major rivers such as the Indus, Ganges, Brahmaputra, Rhine, and Columbia all receive water from glacial sources. Millions of people depend on these rivers for drinking water, irrigation, transportation, and energy production. Hydroelectric power plants, often built in glacier-fed river systems, convert this steady flow into renewable energy, supporting sustainable development and modern economies. As ice melts slowly, it releases water that has been filtered over decades or centuries. This purity supports delicate freshwater ecosystems, including cold water fish species that thrive in stable, oxygen-rich environments. These ecosystems, in turn, support tourism, fishing, and local livelihoods. In polar regions, glaciers influence ocean systems as well. When glaciers reach the sea and calve icebergs, they release fresh water into salty ocean currents. This process affects ocean circulation patterns, which help regulate global climate. Even here, the interaction is gradual, part of a long-running planetary rhythm, rather than a sudden disruption. Glacial lakes form as ice retreats, creating new freshwater reservoirs. Their calm surfaces reflect surrounding landscapes, making them popular destinations for peaceful travel, photography, and relaxation. There's also a quieter role glaciers play beneath the surface. Meltwater often seeps underground, recharging aquifers that supply wells and springs. These hidden water pathways are essential for communities that rely on groundwater, especially in regions where rainfall is limited. Scientists carefully monitor glacier-fed water systems to understand long-term trends, because glaciers respond slowly to changes. Their melt patterns provide insight into broader environmental shifts rather than short-term variability. This makes them valuable tools for planning, water management, agriculture, and infrastructure far into the future. Despite their importance, glaciers never release water all at once. Their melting is typically gradual, unfolding over seasons and years. This slow pace allows ecosystems and societies time to adapt, reinforcing the idea that glaciers are stabilizing forces rather than sudden agents of change. As you rest with this understanding, imagine a drop of water beginning its journey high in a glacier. It waits patiently as ice, then melts gently under sunlight, joins a mountain stream, flows into a river, and eventually reaches the sea. Along the way, it supports life, movement, and growth, all without haste. As we continue drifting peacefully onward, let your imagination travel across the globe, following ice as it settles into many different forms. Glaciers are not all the same. They appear in a wide range of environments, each shaped by climate, geography, and time. From narrow mountain valleys to vast polar expanses, every glacier type plays a unique role in Earth's natural balance. Mountain glaciers are among the most visually striking, found in ranges such as the Himalayas, Andes, Alps, Rockies, and Southern Alps of New Zealand. These glaciers flow down valleys like frozen rivers. They often begin in high cirques and extend downward, sometimes reaching forested areas far below. These glaciers are closely tied to seasonal snowfall and temperature, making them important indicators for regional climate patterns. Valley glaciers are a subtype of mountain glaciers and are particularly effective landscape sculptors. As they move downhill, they carve deep valleys and transport enormous amounts of rock and sediment. Many iconic travel destinations owe their scenery to these glaciers, including Yosemite Valley, Mont Blanc, and Patagonia's dramatic ice fields. Tourism in these regions blends natural wonder with education, offering visitors a chance to witness Earth's slow artistry. Ice caps are broader and flatter than mountain glaciers. They cover large areas of land, often flowing outward in all directions from a central point. Iceland is famous for its ice caps, which sit atop volcanoes and geothermal landscapes. This unique combination of fire and ice creates striking contrasts and supports scientific research into both glaciology and volcanology. The largest and most powerful glaciers on Earth are ice sheets. Greenland and Antarctica host the only remaining ice sheets today. Antarctica's ice sheet is the largest single mass of ice on the planet, containing enough frozen water to significantly influence global sea levels. Despite its immense size, it behaves according to the same basic principles as smaller glaciers, flowing slowly outward under its own weight. Outlet glaciers act as channels through which ice flows from ice sheets into surrounding valleys or oceans. These glaciers can stretch for hundreds of kilometers and move faster than the ice behind them. When they reach the sea, they calve icebergs that drift quietly into polar waters, becoming part of the ocean system. Tidewater glaciers are those that end in the ocean or in deep lakes connected to the sea. Found in Alaska, Greenland, and parts of Patagonia, they are known for their dramatic calving events. Large slabs of ice break off and fall into the water with deep, echoing sounds. Despite their size, these events are part of a steady, natural cycle that has repeated for thousands of years. There are also smaller, lesser-known glaciers that play important roles locally. Rock glaciers, for example, are mixtures of ice and rock that creep slowly downslope. They store frozen water beneath layers of debris, helping regulate water supply in dry mountain regions. Though less visually dramatic, they are vital components of alpine ecosystems. In polar deserts like Antarctica's dry valleys, glaciers behave differently. With minimal snowfall and extremely low temperatures, ice moves very slowly. Some glaciers there appear almost frozen in place, yet they still flow over long periods, demonstrating that motion does not require speed. Each glacier type interacts differently with its environment. Mountain glaciers influence rivers and valleys. Ice sheets affect global climate and sea levels. Coastal glaciers shape marine ecosystems. Together, they form a complex, interconnected system that spans continents and oceans. One calming realization is that glaciers exist on every continent except Australia. From tropical glaciers near the equator to polar ice at the ends of the Earth, frozen water is woven into nearly every corner of the planet. This global presence highlights how deeply glaciers are embedded in Earth's natural systems. As you rest with this global view, imagine ice resting quietly in many forms at once. Some glaciers stretch wide and flat. Others twist through mountains. All of them move slowly, guided by gravity and time, shaping the planet with patience rather than force. As the calm rhythm continues, we shift our attention to a softer side of frozen landscapes. Though glaciers may appear lifeless at first glance, they are deeply connected to ecosystems, both nearby and far away. Life has learned not only to survive alongside ice, but in many cases, to depend on it. In mountain regions, glaciers act as natural reservoirs. During warmer months, meltwater flows gently into rivers and streams, providing a steady supply of fresh water. This slow release supports agriculture, drinking water systems, and hydropower generation for millions of people worldwide. From the Andes to the Himalayas, entire cultures and economies rely on this dependable seasonal rhythm. Glacial meltwater also supports alpine plants that grow in thin soils. These plants are often small and resilient, adapted to short growing seasons and cold temperatures. They stabilize soil, reduce erosion, and create the foundation for food chains that include insects, birds, and mammals. Even in harsh environments, life organizes itself around the presence of ice. In polar regions, glaciers influence marine ecosystems in subtle but powerful ways. When glaciers meet the ocean, their meltwater is cold and rich in minerals. This fresh water mixes with seawater, affecting salinity and nutrient distribution. These conditions often encourage the growth of phytoplankton, tiny organisms that form the base of marine food webs. Phytoplankton blooms support krill, small shrimp-like creatures that are essential to polar ecosystems. Krill feed whales, seals, penguins, and many fish species. In this way, distant glaciers indirectly nourish some of the largest animals on Earth. The connection between ice and life stretches far beyond what the eye can see. Even the ice itself can host microscopic life. Scientists have discovered bacteria, algae, and fungi living on and within glacier surfaces. These microorganisms often give ice a faint coloration, such as pink or gray, especially during summer months. While tiny, they play a role in absorbing sunlight and can influence how quickly ice melts. Glacial lakes, formed when meltwater collects behind natural dams of ice or rock, create unique habitats. These lakes can be extremely cold and low in nutrients, yet specialized organisms adapt to these conditions. Over time, as glaciers retreat, these lakes may become important freshwater ecosystems. Animals in glacial regions display remarkable adaptations. Snow leopards navigate icy mountain slopes with ease, their wide paws acting like natural snowshoes. Arctic foxes change coat color with the seasons, blending seamlessly into snowy landscapes. Penguins huddle together on ice shelves, conserving warmth and energy. Migratory species also rely on glacial systems. Birds follow meltwater-fed rivers during seasonal journeys, stopping to rest and feed. Fish species, such as salmon, depend on cold, oxygen-rich waters influenced by glacial melt for spawning. These migrations support fishing industries and cultural traditions around the world. Human communities have long adapted to life near glaciers. Indigenous cultures in Alaska, the Andes, and the Himalayas hold deep knowledge of ice behavior, weather patterns, and seasonal cycles. Their traditions, stories, and livelihoods are intertwined with frozen landscapes, reflecting generations of careful observation and respect for nature. Glaciers also shape landscapes in ways that benefit ecosystems long after the ice is gone. As glaciers retreat, they leave behind fertile soils enriched with minerals. Over centuries, these areas can become forests, grasslands, or wetlands, supporting biodiversity and economic activities such as farming and tourism. The calming lesson here is that glaciers are not isolated or separate from life. They are active participants in Earth's living systems, quietly influencing water, climate, and biology. Even in silence and cold, they support movement, growth, and renewal. As you rest with these connections, imagine meltwater flowing gently from ice into rivers, into oceans, into clouds, and back again. This slow, circular motion mirrors the steady rhythm of breath and time. Let the pace slow a little more as we drift into one of the most fascinating and gentle roles glaciers play. They are not only rivers of ice, but also quiet historians. Layer by layer, year by year, glaciers record the story of Earth's climate, atmosphere, and environment, preserving memories that stretch back hundreds of thousands of years. When snow falls onto a glacier, it settles softly on top of older layers. Over time, the weight of new snow compresses the layers beneath, turning loose snow into dense ice. Each layer represents a moment in time, much like the rings inside a tree trunk. Winter snow differs slightly from summer snow, creating subtle bands that scientists can read with care and patience. Trapped within these icy layers are tiny air bubbles. These bubbles are samples of ancient atmospheres, sealed away long before modern industry, cities, or technology existed. By analyzing the gases inside them, researchers learn how much carbon dioxide, methane, and other gases were present in the air thousands of years ago. This helps scientists understand how Earth's climate naturally changed long before human influence. Ice cores drilled from glaciers in Greenland and Antarctica are among the most valuable scientific records on the planet. Some ice cores reach depths of more than 2 miles, containing climate information that goes back over 800,000 years. Each meter of ice is like a page in a very old book, written slowly by snowfall and time. Within these frozen pages, scientists also find traces of volcanic eruptions. When volcanoes erupt, they release ash and sulfur into the atmosphere. These particles eventually settle onto glaciers, becoming locked into the ice. Distinct layers of volcanic material help researchers date ice cores accurately and link climate changes to specific events in Earth's geological history. Glaciers also preserve evidence of past temperatures. The ratio of different oxygen isotopes in ice reveals how cold or warm the planet was when the snow originally fell. These delicate measurements allow scientists to reconstruct ancient ice ages, warmer interglacial periods, and long-term climate patterns that shape continents and oceans. Even dust tells a story. Winds carry fine particles from deserts, dry plains, and distant landscapes across the globe. When this dust lands on glaciers, it becomes part of the frozen record. Higher dust levels often indicate colder, drier periods in Earth's past, while cleaner ice suggests warmer and wetter conditions. Some glaciers preserve biological traces as well. Pollen grains trapped in ice reveal what kinds of plants grew nearby thousands of years ago. From this, scientists learn how forests expanded and retreated, how grasslands shifted, and how ecosystems responded to changing climates. Occasionally, glaciers reveal even more dramatic surprises. Ancient tools, clothing, and even human remains have emerged from melting ice. These discoveries provide rare insights into early travel routes, survival strategies, and cultural practices. Ice, in these moments, becomes a guardian of human history. Glacial timelines also help modern society prepare for the future. By understanding how Earth responded to past temperature shifts, scientists improve models that predict sea level rise, water availability, and climate patterns. This knowledge supports education, technology, and long-term planning for cities, agriculture, and global economies. The calm beauty of this process lies in its patience. Glaciers do not rush. They collect, compress, and preserve information slowly, without urgency. Their records are not written in ink, but in snow, air, and silence. As you relax, imagine standing beside an immense wall of ice, knowing that within it lies the memory of countless winters and summers. Each layer formed without awareness of the future, yet now offers guidance and understanding to those who listen carefully. Now let your thoughts drift gently across the planet as we explore some of the world's most well-known glaciers and the peaceful landscapes they help create. These frozen giants are not only scientific wonders, but also sources of natural beauty that support tourism, education, and a quiet sense of awe. In the Alps of Europe, glaciers have shaped some of the continent's most iconic scenery. The Alis Glacier in Switzerland is the largest glacier in the Alps, stretching for more than 14 miles. From above, it resembles a slow-moving river of pale blue ice winding through high mountain valleys. For centuries, it has carved smooth slopes and dramatic ridges, influencing where villages, trails, and alpine travel routes developed. The Alps themselves owe much of their recognizable form to glacial erosion. During past ice ages, thick glaciers filled the valleys, grinding down rock and creating the wide U-shaped valleys that now host picturesque towns, luxury resorts, and scenic railways. Today, visitors traveling for leisure or wellness retreats often walk paths shaped by ice that flowed thousands of years ago. In North America, the glaciers of Alaska dominate vast wilderness areas. The Columbia Glacier, one of the fastest moving glaciers in the world, flows steadily toward the sea. As it calves, large chunks of ice break away and drift into coastal waters, creating floating icebergs that shimmer quietly under northern skies. These icy landscapes support local tourism economies, scientific research, and cultural storytelling among indigenous communities. Glacier National Park in the United States was named for the many glaciers that once filled its valleys. While fewer remain today, their legacy is visible everywhere. Sharp peaks, turquoise lakes, and long valleys all reflect the work of ice. Even as glaciers retreat, they continue to influence water supply, ecosystems, and the rhythm of seasonal change. Moving southward, the Patagonian ice fields of Chile and Argentina form one of the largest ice masses outside the polar regions. Here, glaciers descend dramatically from high plateaus into forests and lakes. The Perito Moreno Glacier is especially famous for its active front, where ice regularly cracks and collapses into the water below. The sound is deep and resonant, echoing across the landscape like a slow heartbeat. Patagonia's glaciers play a vital role in freshwater storage and hydroelectric potential, linking natural beauty with sustainable energy discussions and environmental education. Travelers drawn to these regions often speak of the calming effect of vast open spaces shaped by ice and time. Farther north, Greenland's glaciers dominate much of the island's coastline. Massive outlet glaciers funnel ice from the interior ice sheet toward the ocean. These glaciers contribute to iceberg formation, sending floating ice into the North Atlantic. Historically, these icebergs influence shipping routes, navigation, technology, and even global trade patterns. In Iceland, glaciers sit alongside volcanoes, creating a rare and striking combination of fire and ice. Vatnajökull, Europe's largest glacier by volume, covers active volcanic systems beneath its ice. Meltwater from geothermal heat forms ice caves, subglacial rivers, and sudden floods, known as J-clopes. These natural processes are studied closely to improve safety, infrastructure planning, and disaster preparedness. The glaciers of the Himalayas are often called the third pole because of their immense ice reserves, feeding major rivers such as the Ganges, Indus, and Brahmaputra. These glaciers support hundreds of millions of people downstream. Agriculture, urban development, and economic stability across South Asia depend on the steady release of meltwater during dry seasons. High in the Andes, tropical glaciers exist surprisingly close to the equator. Though smaller, they are vital water sources for cities like Lima and La Paz. Their presence reminds us that glaciers are not limited to polar regions, but exist wherever climate and elevation allow. Across the world, these glaciers quietly sculpt landscapes that influence culture, travel, architecture, and lifestyle. They shape where roads are built, where communities settle, and where people seek moments of calm and connection with nature. As you settle deeper into relaxation, imagine these glaciers resting under starlight, slowly moving, shaping valleys without sound or urgency. In the next part, we will explore how glaciers interact with oceans and seas, and how ice and water share a gentle, powerful relationship. Now let your breathing slow even further as we follow glaciers to the places where they quietly meet the ocean. Along coastlines and fjords, ice and water interact in ways that shape marine ecosystems, influence global climate systems, and create some of the most peaceful landscapes on Earth. When a glacier flows into the sea, it becomes what scientists call a tidewater glacier. These glaciers end directly in salt water, where the ice front rises like a frozen cliff above gentle waves. Over time, the glacier releases ice through a process known as calving. Large blocks detach and drift away as icebergs, floating slowly across the surface of the ocean. This process is natural and has occurred for thousands of years. The rhythm of calving is often calm and unpredictable, marked by long periods of stillness followed by a deep, echoing splash. For travelers and researchers alike, witnessing a glacier calve is a moment of quiet awe, blending natural beauty with scientific curiosity. Fjords are one of the most visible results of glaciers reaching the sea. These long, narrow inlets with steep sides were carved by glaciers during ice ages. When the ice retreated, seawater filled the deep valleys. Norway's fjords are among the most famous, supporting coastal communities, fishing economies, and a thriving tourism industry centered on nature and slow travel. In Alaska, fjords formed by glaciers are home to rich marine ecosystems. Cold, nutrient-rich meltwater mixes with ocean currents, supporting plankton growth. This abundance of life attracts fish, seabirds, seals, and whales. Glaciers indirectly shape food chains that extend far beyond the ice itself. Greenland's outlet glaciers contribute a significant number of icebergs to the North Atlantic. These icebergs can drift for months, gradually melting as they travel south. As they melt, they release fresh water into the ocean, subtly influencing salinity and circulation patterns. Oceanographers study these processes closely because they affect climate systems and weather patterns worldwide. In Antarctica, glaciers feed massive ice shelves that float on the ocean's surface. These ice shelves act like brakes, slowing the flow of glaciers behind them. When ice shelves thin or break apart, the glaciers inland can accelerate toward the sea. This connection between land ice and ocean water is an important focus of modern climate science and environmental education. Despite their power, these interactions often appear serene. Icebergs glow softly in shades of white and blue, reflecting sunlight and moonlight. Beneath the surface, meltwater creates gentle currents that influence temperature and nutrient flow. For many people, watching ice meet water has a calming, meditative effect. Glacier-fed seas also shape human culture. Coastal indigenous communities in polar and subpolar regions have long understood the rhythms of ice and ocean. Traditional knowledge includes careful observation of iceberg movement, seasonal changes, and safe travel routes. This cultural wisdom complements modern science and supports sustainable living practices. In places like Patagonia and southern Chile, glaciers reaching fjords create striking contrasts between ice, forest, and sea. Tourism here often focuses on slow exploration, quiet boat journeys, and educational experiences that emphasize respect for nature. These regions demonstrate how glaciers contribute not only to physical landscapes, but also to economic and cultural identity. As glaciers melt into the ocean, they remind us of the interconnectedness of Earth's systems. Ice, formed from ancient snowfall, eventually becomes part of the global ocean, linking mountains to seas in a continuous cycle. This slow exchange shapes coastlines, influences climate, and supports life across the planet. Let this image linger in your mind: calm water, drifting ice, and the steady, timeless movement of glaciers meeting the sea. In the next part, we will explore how glaciers preserve history, storing ancient air, landscapes, and climate records within their ice. As the world grows quieter, let your thoughts drift inward toward the idea that glaciers are not only moving rivers of ice, but also vast, frozen libraries. Within their layered depths, glaciers preserve stories of Earth's past, stored patiently for thousands, sometimes hundreds of thousands of years. Each year, snowfall adds a thin new layer to a glacier. Over time, these layers compress into ice, trapping tiny bubbles of air, particles of dust, traces of volcanic ash, and even microscopic organisms, like pages in a book. These layers stack one upon another, creating a chronological record of environmental conditions stretching far into the past. Scientists study this frozen archive through ice cores by carefully drilling long cylinders of ice from glaciers and ice sheets. Researchers can analyze the layers in detail. Some ice cores from Antarctica reach back more than 800,000 years, offering a rare glimpse into ancient climates long before human history. The air bubbles trapped inside glacial ice are especially valuable. They contain samples of Earth's ancient atmosphere, allowing scientists to measure past concentrations of carbon dioxide, methane, and other gases. These measurements help researchers understand natural climate cycles, ice ages, and warm periods, providing essential context for modern climate science and education. Dust particles within glaciers tell stories of distant deserts and shifting winds. During drier periods, winds carried more dust into the atmosphere, which eventually settled onto ice surfaces. By studying these dust layers, scientists can learn about past droughts, wind patterns, and even changes in vegetation across continents. Volcanic eruptions leave clear signatures in glaciers as well. Ash from major eruptions settles on ice, creating distinct dark layers that can be precisely dated. These layers help synchronize climate records across different regions of the world and allow scientists to study how volcanic events influenced global temperatures and ecosystems. Glaciers also preserve evidence of human history. In melting ice, archaeologists have discovered ancient tools, clothing, and travel routes once hidden for centuries. In the Alps, retreating glaciers have revealed prehistoric artifacts that show how early humans moved through mountain landscapes and adapted to cold environments. In polar regions, glaciers have preserved remains of long-extinct plants and animals. Pollen grains trapped in ice provide clues about ancient forests and grasslands. These findings help scientists reconstruct ecosystems from different geological eras, deepening our understanding of biodiversity and natural change. The stability of glaciers makes them uniquely reliable record keepers. Unlike oceans or forests, where materials mix and decay, glacier layers remain relatively undisturbed. This consistency allows for precise dating and long-term comparisons, supporting research in geology, climate science, and environmental history. Modern technology has enhanced the study of glacial records. Advanced laboratories analyze isotopes in ice to determine past temperatures. Satellite imagery helps scientists map glacier changes and select optimal drilling locations. These tools connect ancient natural archives with modern technology and global research collaboration. Despite their scientific importance, glaciers reveal their secrets quietly. There is no rush, no urgency in their frozen layers. Each piece of data is released slowly as ice melts or is carefully extracted. This slow pace mirrors the calming rhythm of glaciers themselves, making them symbols of patience and deep time. Understanding glacial history also shapes our future by learning how Earth responded to past climate changes. Scientists and policymakers gain insight into potential future scenarios. This knowledge supports sustainable planning, environmental education, and global cooperation. As you rest with these thoughts, imagine glaciers as silent witnesses, holding memories of snowfall, sunlight, storms, and calm. In the next part, we will explore the living world that depends on glaciers, from tiny microbes to entire ecosystems shaped by ice. As the quiet rhythm continues, let your imagination drift to the edges of glaciers, where ice meets rock, water, and life. Though glaciers may appear barren and still, they quietly shape ecosystems that support an astonishing range of living organisms. From microscopic life to large animals and human communities. At the surface of glaciers, tiny organisms known as cryoconite microbes live within small pockets of dark dust and sediment. These microbes include bacteria, algae, and fungi that survive in extreme cold, low nutrients, and intense sunlight. Their presence slightly darkens the ice, increasing heat absorption and subtly influencing melt rates. Even in the coldest environments, life finds a way to adapt. Meltwater flowing from glaciers forms streams and rivers that nourish ecosystems far downstream. These glacial rivers carry minerals ground from rock beneath the ice, enriching soils and supporting agriculture, forests, and wetlands. Many communities depend on this steady flow for drinking water, hydroelectric energy, and irrigation, linking glaciers to modern economies and sustainable development. In mountainous regions, glacial melt creates alpine meadows that bloom briefly during summer. These meadows support insects, birds, and grazing animals, forming seasonal ecosystems finely tuned to the rhythms of snow and ice. Tourism in these regions often centers on these dramatic landscapes, blending natural beauty with cultural and economic significance. Cold, sediment-rich, glacial waters support unique aquatic life. Some fish species, such as certain trout and salmon populations, thrive in glacial rivers where water temperatures remain low year-round. These species are essential to both natural food webs and cultural traditions, particularly for indigenous communities with long histories of fishing. Glacial fjords, carved by ancient ice, host rich marine ecosystems. Nutrient-rich waters support plankton, which form the base of food chains that include fish, seabirds, and marine mammals. In places like Alaska, Norway, and Greenland, these fjords are both biodiversity hotspots and destinations for nature, tourism, and education. Plants colonizing newly exposed land left behind by retreating glaciers follow a predictable pattern known as ecological succession. First come hardy mosses and lichens, followed by grasses, shrubs, and eventually trees. This gradual transformation offers scientists a living laboratory to study how ecosystems develop over time. Large animals also rely on glacial environments. Species such as mountain goats, snow leopards, and polar bears depend on cold habitats shaped by ice. Glaciers influence migration routes, hunting grounds, and seasonal behavior, making them critical to wildlife conservation efforts. Human cultures have long adapted to glacial landscapes. Indigenous peoples in the Arctic and high mountains developed deep knowledge of ice behavior, weather patterns, and seasonal cycles. Their traditions, stories, and survival strategies reflect a respectful relationship with frozen environments, blending culture and geography. As glaciers retreat, ecosystems adjust, sometimes slowly, sometimes abruptly. New lakes form, river flows change, and habitats shift. Scientists monitor these changes closely to understand how life responds to environmental transitions, helping guide conservation and climate adaptation strategies. Despite the challenges, glacial ecosystems demonstrate resilience. Life persists in cold, shifting conditions, adapting creatively to change. This resilience offers lessons for humanity, reminding us of the interconnectedness of nature and the importance of balance. As you continue to relax, imagine standing quietly at the edge of a glacier-fed river, listening to water flow steadily over stone. In the next part, we will explore how glaciers shape landscapes through erosion and time, carving valleys, mountains, and coastlines. Let your thoughts drift now to the slow, patient work glaciers perform as they move across the earth, long before cities, borders, or written history. Glaciers acted as powerful sculptors, shaping landscapes with a quiet persistence that unfolded over thousands, sometimes millions of years. As glaciers advance, they behave like immense rivers of ice, pressing downward with enormous weight. Beneath them, rock is slowly ground away through a process known as abrasion. Stones frozen into the base of the ice scrape against bedrock, polishing surfaces smooth and carving fine lines called striations. These markings still remain visible today in many mountainous and northern regions, silent records of ancient ice movement. Another process, plucking, occurs when meltwater seeps into cracks in the rock beneath a glacier. As temperatures fluctuate, the water refreezes and expands, loosening chunks of stone that become embedded in the ice. When the glacier moves, it carries these rocks away, reshaping the terrain below and transporting material across vast distances. One of the most recognizable landforms created by glaciers is the U-shaped valley. Unlike rivers, which carve narrow V-shaped valleys, glaciers widen and deepen entire landscapes as they flow. When the ice eventually melts, it leaves behind broad valleys with steep sides and flat floors, now often home to rivers, roads, towns, and fertile agricultural land. Cirques form high in mountainous regions where glaciers begin. These bowl-shaped depressions collect snow that gradually compacts into ice. Over time, cirques deepen and widen, sometimes forming sharp ridges known as arêtes between neighboring glaciers. Some of the world's most dramatic alpine scenery owes its beauty to these features. Glaciers also carve fjords along coastlines. When glaciers extend into the sea, they erode deep valleys below sea level. After the ice retreats, seawater floods these valleys, creating long, narrow inlets bordered by steep cliffs. Fjords are now important centers for tourism, fishing, and marine research, blending natural grandeur with modern economic activity. Moraines are another legacy of glacial movement. These ridges of rock and sediment are deposited along the edges or at the terminus of glaciers. Terminal moraines mark the furthest advance of ice, offering scientists valuable clues about past climates. Today, moraines often support forests, trails, and settlements, integrating geological history into everyday landscapes. Drumlins, smooth, elongated hills shaped beneath glaciers, reveal the direction of ice flow. These formations are common in regions once covered by continental ice sheets, such as Canada, Northern Europe, and parts of the United States. From the air, drumlin fields resemble gentle waves frozen in time. Glacial lakes form when meltwater collects in depressions carved by ice or behind natural dams of sediment. Many famous lakes, including those in the Alps, the Rockies, and Scandinavia, owe their existence to glaciers. These lakes support freshwater ecosystems, recreation, and tourism, contributing to local economies and cultural identity. Even coastlines bear the signature of glacial influence. As ice sheets melted after the last ice age, sea levels rose, reshaping shores worldwide. Some regions experienced isostatic rebound, where land slowly rises after being freed from the weight of ice. This ongoing process continues to alter landscapes today, demonstrating that Earth's surface remains dynamic. Glacial erosion also exposed valuable mineral resources by stripping away surface layers of rock. In some regions, this has influenced mining, industry, and economic development. While resource extraction must be balanced with environmental protection, glaciers have undeniably shaped patterns of human settlement and industry. As you rest with these thoughts, imagine a mountain range slowly emerging beneath retreating ice, valleys opening to sunlight for the first time in millennia. In the final part, we will gently reflect on glaciers as storytellers of Earth's past and guides for its future. As we arrive at the final stretch of this calm journey, allow yourself to settle into the idea that glaciers are more than ice. They are timekeepers, quietly preserving Earth's memory, layer by layer, holding stories that stretch back far beyond human history. Each glacier contains a frozen archive. Snowfall accumulates year after year, compressing into ice and trapping tiny bubbles of ancient air. These air pockets preserve the composition of Earth's atmosphere from centuries and even hundreds of thousands of years ago. By studying ice cores drilled from glaciers and ice sheets, scientists can measure past levels of carbon dioxide, methane, and other gases, helping us understand long-term climate cycles. Ice cores also contain traces of volcanic eruptions, dust storms, sea salt, and even pollen. A distant eruption can leave a thin ash layer embedded in ice, serving as a precise timestamp. In this way, glaciers act like natural libraries, storing chapters of Earth's environmental history with remarkable clarity. The oldest ice ever recovered comes from Antarctica, dating back more than 800,000 years. These records reveal patterns of ice ages and warmer interglacial periods, showing how Earth's climate naturally shifts over long timescales. Such insights are essential for education, climate science, and informed global decision-making. Glaciers also teach us about patience. Their movement is slow, often just a few centimeters or meters per day, yet their impact is profound. This quiet pace reminds us that not all change is sudden. Some transformations happen gradually, shaping the world in ways that only become visible over generations. In many cultures, glaciers hold spiritual and cultural significance. Indigenous communities in the Andes, Himalayas, and Arctic regions have long viewed glaciers as living entities or sacred ancestors. These beliefs reflect a deep understanding of the interconnection between ice, water, agriculture, and survival. Glacial meltwater continues to sustain rivers that support cities, farms, and ecosystems. From hydroelectric power generation to irrigation, glaciers quietly contribute to modern economies and sustainable energy systems. In this sense, ancient ice supports contemporary life, linking past and present. At the same time, glaciers are sensitive indicators of environmental change. Their retreat or advance reflects shifts in temperature and precipitation. Monitoring glaciers helps scientists forecast water availability, sea level rise, and natural hazards such as glacial lake outburst floods. Despite their vulnerability, glaciers also demonstrate resilience. In colder regions and higher elevations, some glaciers remain stable or even grow, responding to localized climate conditions. This complexity reminds us that Earth systems are interconnected and nuanced. As night settles in and your thoughts grow lighter, imagine glaciers under starlight, reflecting moonbeams across silent valleys. They continue their slow journey, shaping landscapes, storing memories, and feeding rivers long after we drift into sleep. Thank you for spending this peaceful time exploring the frozen wonders of our planet. Wherever you are in the world, may this gentle journey through ice and time bring calm, curiosity, and rest. And now, you can simply breathe and let the quiet carry you into sleep.